Question number 24. The dashed line on the graph shows a variation with the wavelength of the intensity of solar radiation before passing through the Earth's atmosphere. Okay, so this is the solar radiation. It tells you like what kind of wavelengths are being emitted at what temperature and what kind of wavelengths have been received in the Earth's atmosphere, right? Then the solid line on the graph shows a variation in the wavelength on the intensity of solar radiation after it has passed through the Earth's atmosphere. See, on the y-axis it is intensity and this time it is wavelength over here. Okay, so it shows you about what is the intensity after it passes through the Earth's atmosphere. And shown here is a shaded graph over here which tells you about the visible region. See here, if you look at this, this is 0.4 here and this will be 0.5, 0.6, 0.7 here. 0.7 here, which means the wavelength spans from 400 nanometers to 700 nanometers. Okay, now everything else is given here. Which feature of the graph explains the greenhouse effect? What is greenhouse effect? Greenhouse effect is nothing but absorption of IR radiation. IR radiation in the atmosphere. This is what, sorry, not absorption, it is a reflection, not absorption, it is a reflection of IR radiation in the atmosphere. So now if you look at this carefully here, see this appears like, for example, if the peak is going upwards, this is an emission spectra. If the peak comes out to be downwards, sharp peaks like this are called as absorption spectra. So you see that this is being seen only beyond the red region here. What does this region correspond to? This particular region corresponds to your IR radiation, right, after red, right? So this, you write it as a wave gear over here. Okay, this beyond red is called as IR and below violet is called as UV. Okay, so because you just remember it like this, V for violet here, R for red over here. So this is the region which corresponds to red over here, and you see the intensity getting dropped here. What do you mean by getting dropped? Which means part of it is absorbing over here. Okay, so therefore infrared absorb. Now let us look at the options over here. It says the infrared radiations is absorbed at specific wavelengths. Definitely true, because you don't get something like a big peak like this. You don't get a peak like this, right? You don't get a broadened one. But you see only at specific wavelengths is getting absorbed over here. So A is the right answer. Okay, the rest of them are incorrect. Okay.